Hello and welcome to the National Spectrum Consortium Spotlight Series. I'm Sal D'Itri, the chairman of the National Spectrum Consortium. This is the second in our Spotlight series, 5-minute interviews we're doing that showcase NSC members. Now let me introduce David Debrecht, National Spectrum Consortium Executive Committee member and U.S. Major CTO for Nokia here in the United States. Our theme for today is 5G standards. Thanks for joining us, David.
Yeah, thanks for having me on, Sal.
You bet. Yeah, you do an amazing job on the XCOM. We thank you for that. But tell us a little bit about what your day job is at Nokia.
Yeah, I started my career in the defense industry, actually working at General Dynamics and Lockheed Martin. Transitioned to telecom, specifically wireless, in the mid-90s with Nokia, and I've been with them ever since. My current role at Nokia is CTO for our U.S. majors and federal business, which basically means all of our U.S. customers other than the big ones like AT&T, Verizon, and the new T-Mobile. It's been a very interesting few years, decades actually, starting with the introduction of 2G back in the 90s in the U.S. to now 5G dominating the global communications discussion.
Okay, well, let's get on to it and talk about 5G standards. Over the past few years, 3GPP has published series of 5G standards. So much talk today about release 15, release 16 potential. How do the standards work and what do they mean for U.S. technology, innovation, and development?
So 3GPP is the main standards organization for 5G and cellular technology in general. The standards are essential for wireless evolution as well as creating an open and global ecosystem. It originated back in the 90s to develop the third generation global standard based on the success of GSM, which is known as 2G. It unites 7 organizational partners that are organized regionally, including ATIS here in the US and SC in Europe, as well as 5 others from around the world. The primary purpose is to provide their members with a stable environment to produce the specifications that define 3GPP technologies. It's organized into 3 main areas: services and systems aspects, or the SA group, core network terminals, that's the CT group, and then radio access networks, or RAN. The industry has learned over the years that standards-based development is critical to the success of the technology. So any 5G development or technology contributions from the US need to be done under the 3GPP framework.
So within that framework, how does one go about influencing a 3GPP standard?
Yeah, that's a good question. There are a couple of key ways you can influence the standards. One is directly by joining 3GPP and sending delegates to the meetings, participating in studies and the development activities. The other is indirectly through a group or organization that share common interests, like an industry vertical. There are many examples of this, like the Automobile Association or the Global Unmanned Aircraft Traffic Management Association. These industry groups develop their own requirements offline and then work with 3GPP members and delegates to include the requirements into the standards.
Yeah, you know, with 5G, it's a cliche that it's not just an evolution, but a revolution. But from a standards perspective, how does 5G differ from previous generations?
In general, the main focus of 3GPP as an organization is to develop backward and forward compatible standards. So in a sense, evolution. But with 5G, we've seen some aspects of revolution as well. Currently today, you can see 5G deployments with a mode called non-standalone, or NSA. That includes the 4G core with a 5G radio. So in that aspect, it's an evolution. But having said that, there are some key differences between 5G and the previous generations. 2G and 3G were frequency division duplex, or FDD only, and 4G was mostly FDD, but 5G is mainly time division, or TDD. So that's one big difference. Another is the spectrum support. 5G new radio can be deployed over a wide range of spectrum from 600 megahertz all the way to 100 gigahertz, with channel bandwidths of 20 megahertz to hundreds of megahertz. And that's just not the case with 4G. But the largest difference, and probably where the view of the revolution comes from, is the support for new use cases through a completely new network architecture. This puts 5G right in place to create what Nokia calls the fourth industrial revolution.
So you talked about use cases. We've got these RPPs that are out through the consortium. How do standards influence these technologies like augmented and virtual reality, the smart warehouse, and even future mid-band spectrum sharing, so critical to our national 5G strategy?
Yeah, the 5G standard provides for a wide variety of network capabilities. The combination of network slicing and these capabilities enable a broad range of use cases, from traditional high-speed broadband to ultra-reliable low-latency communications to massive machine-type communications. Those are essentially the three pillars of the 5G network: eMBB, URLLC, and MMTC. The network will be able to provide very high definition video, latency sensitive applications, and very large numbers of devices. Various combinations of these attributes allow for the use of lots of different use cases you were talking about: smart warehouses, smart bases, AR, VR for training or interactive development, autonomous vehicles, drones, video surveillance, and a lot more use cases that we haven't talked about yet. And it allows for the mid-band spectrum that you mentioned earlier, as well as millimeter wave, which is mostly what 5G has been deployed so far.
Yeah, I don't know if you heard in the background, but the National Spectrum Consortium cat just walked by our interview. But, such is life these days.
Yeah.
Finally, just one last question from your perspective. How do governments think about 5G standards compared to the private sector? How can governments influence 5G standards?
Yeah, great question. So the first thing that comes to my mind with that question is security. Obviously, security is important in the private sector, but it's critical for government and military applications. So the security aspects of 5G should be one of the first things that's considered. I know there are several agencies in the government trying to influence the standards now, and NIST is currently working to test and demonstrate 5G security in the lab. Outside of security, I'd say that the applications and the use cases for the networks are going to be different, but 5G networks will be able to support both. Flexibility was considered critical in the early days of the 5G development and was designed into the standards and specifications.
Yeah, thanks for that. It's all the time we have for today. Many thanks to David Debrecht for joining us, and thanks to everyone for watching. Feel free to reach out to David or myself if you have any questions about 5G standards. Thank you for watching.